All right, guys, so today you are, for 3 days, you're going to have a sub due to the fact that I am going to visit my friend in California who just had a baby. So thank you so much for being good for my sub. Please note that if your name gets written down, I do have to write a referral for you. Okay, so if you have any questions, feel free to email me. I will be answering my email as quickly as I can, and if I need to, I can go over things with you via email or a video if I can. Okay, so today you're doing interpreting slopes, intercepts, and points. This is on Wednesday, October 2nd. Okay, so the date is October 2nd. All right, your essential question: can I identify and interpret slopes, intercepts, and points in a real-world problem? Can I evaluate a situation in order to determine if the variables have a relationship that is associated or caused? Okay, so let's remember what slope is. The rate of change, or slope, is a ratio that describes, on average, how much one quantity changes with respect to a change in another quantity. Okay, so what you're going to do is it's going to give you the problem will give you some information, mainly because I'm not going to give you just a giant word problem. We're going to start with like the little things. So it'll give you some information, and then you need to first find the slope, and then second, you need to determine what it means. So if we look at this table right here, I have computer games on one side and the cost on the other. And actually it gives you some information. It tells you this is X and this is Y. So it already gives you what's the independent and what's the dependent. So the slope, we're going to go to Desmos. So let's make we're going to go to Desmos. Because whenever we have a table, we can find the slope quickly by using Desmos. Okay. And my picture, for some reason, I cannot move this. I don't know why. So I'm just going to hit enter, enter, enter until you can see what I'm typing. Table. And I have 278, 4, 156, 6, 234. I don't want you to pause your video and try and do this with me. I just want you to watch what's happening because you should already know how to do this, okay? So then after your equation that you typed, to always find it is y1 squiggle line mx1 plus b. Okay, and it does give me my slope. It tells me my slope is 39. 39. So on your paper, we're going to write 39. We don't know what that means in this problem situation. So we have to remember that slope is always y per x. And in this problem situation, because it's always the vertical change over the horizontal change, okay? And vertical is y, horizontal is x, okay? So what you're going to do is you're going to put the y value here of what it is over the x value. So here you're going to put money per computer game. So the meaning here is going to be the cost per computer game. The cost per computer game. Okay, let me pause here. What's up, Roxanne? Okay, I'm trying to record a video. Okay, so, okay, all right. All right, sorry about that. So the next problem situation, it gives you a graph, and you're going to find the slope of it using the graph, okay? Then we're going to talk about what it means. So looking at a graph, you have to first find good points, and they're nice enough here to give you good point. Well, that's not a good point, but we're going to use this one right here, okay? So if you look at the vertical change on this one, the vertical change, how much it's going up, okay, from 160 to 180, that is a change of 20, okay? So remember, let me zoom in on this so y'all can see. So right here, this is a good point and that's a good point. So I go up, I'm going up 20. Now, so in the past we've just done count how many. The rise over run is 1 over something. However, in this case, we have to consider this is not going to be just 1. Okay, so we have to look at what y means, because sometimes on graphs they don't do that. All right, then here, this change, I go from 40 to 20, which is another 20. So now my slope is going to be 20, and I went backwards 20, so it's that. All right, 20 over negative 20, and that equals negative 1. All right, so again, what we did here is we counted the vertical change going up, and each box here represents 20. So instead of just doing 1, it's 20. And then I went backwards from 40 to 20, which is another 20. Okay. So the meaning here is going to be the y per x. So we can just play around with that in our heads. We can say the heart rate per age, the maximum heart rate per age. But that doesn't make sense to say the maximum heart rate per age. So we're going to say the maximum heart rate for your age. HR for, we're going to say one's age. Okay, so that means that for every decrease in the heart rate, the age would go up 1. Okay? So as the heart rate decreases by 1, the age goes up by 1. So the meaning here of this point of 20, 180 is that when you have a 20-year-old, the heart rate for that person, the maximum heart rate is 180 beats per minute. Year-old, the max heart rate is 180. All right, now let's talk about intercepts. So that's slope. So again, you can use Desmos for tables. For these, you can count the slope. So the blank intercept is the initial value of the dependent variable or output. So whenever I'm talking about output, that's my y. The blank intercept is the value of x when the y value equals 0, so that's the x-intercept. Okay, so in problem situations, let's look at what that looks like. Use the table to determine and describe the x and y intercepts of the situation. So I have some months here, and I have the amount left to pay for the TV. So I'm going to go to Desmos, and I'm going to graph these points, so that way I can look at it. Rid of my picture. $80, $670, and $860. Okay, I can't see my points, so I need to zoom out. There they are. All right. So what's happening here is it's decreasing, and if we look at the problem situation, as the months go up, the amount left to pay for the TV is going down. So we can make a line. I'm going to make a line, y1, squiggle line, mx1 plus b. Okay, and then what I can, once I have that, now I have my y-intercept. So let's think about what the 0 and the 100 mean in this situation. So this would be 0 months. After 0 months, I have $100 left to pay for the TV. So the y-intercept is 0, 100. And in the problem situation, that means that when I started, I had $100 left to pay for the TV. Starting cost of the TV. Now the x-intercept, if I go back to Desmos, I can find it. Right there, it's 20. And so that's 20 months, I would have $0 left to spend on the TV. So 20, 0. And that means at 20 months, the TV would be paid for. Okay. All right, so X and Y intercepts. Today what y'all are going to do is you're going to take this and it's a digital file, and you're going to slide these onto this file and make a match with the verbal description, the y-intercept, and the meaning of the y-intercept. Okay, once you're finished with that, on the back there's a discussion about causal and association, and you're going to answer those questions and decide whether it's causation or association. So let's talk about what that means. Association means that the data is related in some way, but causation means a change in one causes the change in the other. Okay? Determine if the situation is association, causation, or neither. The number of pets a person has and the number of times they go to the pet store. Okay? Does the number of pets that I have cause me to go to the pet store more? Yes. So that's a causation. If I have more cats, then I need to go buy more cat litter. If I have more dogs, I need to go buy more dog food. The number of cats a person has and the amount of cat food they buy. That's causation. The number of chickenpox vaccines given and the number of chickenpox cases reported. Does the vaccine actually cause the case to be reported? No. So this is going to be association. Because the vaccines do not cause the cases to be reported. Okay. Now up here, this could be either. This could be causation or association, because there's also, what if I have a bunch of pets, however, I don't feed my pet, I don't take care of them. So this could be either one. I would take either on that. Okay, so what y'all are going to do today, let me show you your assignment. It's in Canvas. You go here, it's slopes and intercepts. Okay, and you're going to create a copy of the following slides file. So let me go here, and you're going to make a copy. Call it whatever you want to call it. Okay, now this is your file. You're going to mess with it. Okay, if you need to zoom in, you need to zoom in because you can't see. All right, so this is the paper that you have right here. This is the paper that you have right here. These are shuffled. But what I've done is I've clipped them. Okay, so these are shuffled on this page. Do not give me this page just like it is, because these are not the answers. Okay, so y'all are going to go here. Again, if you need to zoom in, you need to zoom in. All right, and I have these situations here. I have a graph, and I have another graph, a table, and then an equation. All right, and these are the situations that are happening. So Arlene began her stamp collection with 25 stamps. Each week she receives 5 new stamps. Okay, an aquarium holds 200 gallons of water and drains at a rate of 20 gallons per minute. Okay, since I like this one, since I'm draining, would I be increasing? That would be inaccurate. Okay, so I'm not going to be increasing. And if you look here, I start with 200 gallons of water. And the only one that makes sense right here, I'm losing 20 each time, so this is going to come down here. I'm going to slide that right there. Okay, then I'll go up here again and look at these problem situations and fit them. Okay, when I get to the y-intercept, these are the y-intercepts. These are the description of the y-intercepts. These are the x-intercepts. Then go over here. I'm going to do the same thing. Now on the back, on the next page, you have what is another name for the starting point of the situation. It says double click to add text. So right here you can delete what this is, and then you're going to type your answer. The starting point in a situation means ... and finish that. Okay, what is another name for the rate of change? Again, double click and you can type. All right, right here, please either enter either a C or causation and an A for association. So right here, you're going to double click, and then you can delete whatever you need to delete. Okay, when you get ready to turn this in, you're going to go here. Let me switch to student view so that way y'all can see. Oh, and I didn't publish it. Show you what this looks like. So you're going to go here. When you get ready to submit, you'll click submit, and you're going to go to your Google Drive. And it's not, tool's not available, but then you'll click and you'll search for this name, and then you can click submit assignment. Okay, submit assignment there. All right, if y'all have any questions, feel free to email me. This is due today, but if you need help, go see another teacher. There's Ms. Dorfler or Coach Taylor that you can go see. The other option, I know Ms. Dorfler has tutorials this Wednesday afternoons. The other option, you can email me and I can answer you via email. All right, y'all have a wonderful day. Make sure you're good for my sub.